In this video, we're going to go over the KutaSoftware Infinite Calculus free worksheet, differentiation, power, constant, and sum rules. Let's quickly define each of those rules. First, let's look at the constant rule. The constant rule says that if c is a real number, then the derivative with respect to the variable, so with respect to x, of a constant c, that is going to be equal to 0. Because if you think about it, a constant, when graphed, is a horizontal line with a slope of 0. So the tangent line always has a slope of 0, therefore the derivative is always 0. Now, for the power rule, if we're taking the derivative with respect to x of some function x to the n, then the power rule says that the derivative of x to the n is equal to n times x to the n minus 1. So essentially, we're multiplying the coefficient of x by n. So if the coefficient is 1, n will get multiplied by 1. If the coefficient is 2, n will get multiplied by 2, and so on. So we're multiplying that coefficient by n, and then we're decreasing that exponent by 1, and that is the derivative. Another way to write this rule would be the derivative with respect to x of ax to the n, showing that we could potentially have a constant. Then that would be n times a times x to the n minus 1. So again, one more time, we're taking the exponent and multiplying it, and then we're decreasing that exponent by 1. That is the power rule. But what if there's a constant that's multiplied by x? Well, that's where the constant multiple rule is applied. And the constant multiple rule states that if we're taking the derivative with respect to x of some constant c multiplied by f of x, then we'll multiply that constant by the derivative of f of x. Let's say that this was negative x to the n, then we would have negative n times x to the n minus 1, because that's the same as multiplying by a negative 1. Now, onto the sum rule. The sum rule says that if we're taking the derivative of some function f of x plus some other function g of x, if we're taking the derivative of the sum of those, then we can write that as the derivative of f of x plus the derivative of g of x. So we can take the derivative of those terms separately. And because of this sum rule, it leads directly into another rule, the difference rule, which I'll go over as well. So think about this. F plus negative g is equivalent to f minus g. Therefore, the derivative with respect to x of f of x minus g of x is going to be equal to the derivative of f of x minus the derivative of g of x. So now that we've gone over those, let's jump into our worksheet. It says to differentiate each function with respect to x. And remember, we need to watch the notation. So if we're talking about y, we're going to find dy dx. If we're talking about the function of x, we're going to find the derivative of f of x. That is our notation. So for y equal to 5, we can apply the constant rule. Remember, for the constant rule, we said that the derivative with respect to x of a constant c is equal to 0. In this case, our constant c is 5, and we're taking the derivative of y. So we'll have dy dx, the derivative of y with respect to x, is equal to 0, because 5 is a constant. So in number 2, we have f of x equals 5 times x to the 18th. So in number 2, you can see that we're going to need to use the power rule. However, we have a constant out in front of our function, so I'm going to also apply that constant multiple rule, which says that the derivative with respect to x of c times f of x, that equals c times the derivative of f of x. So pulling that 5 out, we'll have 5 times the derivative of x to the 18th. And we need to apply that power rule. Remember, the power rule is the derivative with respect to x of x to the n, that equals n times x to the n minus 1. So we're bringing down that value of that exponent, which in this case is 18, and we're decreasing that exponent value by 1. So we'll have 5 times n of 18 times x to the n minus 1, 18 minus 1. So that's 5 times 18 times x to the 18 minus 1, which is x to the 17, and 5 times 18 is 90. So 90x to the 17th is the derivative of f of x. So again, we applied the constant multiple rule by pulling this 5 out of the function in front, and then we found the derivative of x to the 18th and multiply that by the 5 which we pulled out. So x to the 18th became our new function once we pulled 5 out. So we found the derivative of that x to the 18th, then multiplied it by 5 to give us that the derivative of f of x equals 90 times x to the 17th. Let's move on to number 3. In number 3, we have that y equals 4x to the 5th plus x. So we can think of this as f of x plus g of x. So we're going to be using the sum rule to find the derivative, which will be the derivative of f of x plus the derivative of g of x. So looking at this first term, 4 times x to the 5th, we're going to need to use the constant multiple rule, and we're going to need to use the power rule. So we're going to have 4 times the derivative with respect to x of x to the 5th plus, there's no constant in this one, so it's just the derivative with respect to x of x. So we'll have 4 times the derivative with respect to x using the power rule for x to the 5th, that's going to be n times x to the n minus 1, which where n is 5, that's 5 times x to the 5 minus 1, and we're adding that to the derivative of x, but in this case, our exponent of x is 1, so that's going to be 1 times x to the 1 minus 1. So using the power rule for that, bringing down that exponent value of 1, and then decreasing it by 1, we'll have 4 times 5, which is 20, times x to the 5 minus 1, which is x to the 4th, plus 1 times x to the 1 minus 1, which is 1 times x to the 0, and x to the 0 is 1. So multiplying 1 by 1 will give us 1. So our derivative of y with respect to x is equal to 20x to the 4th plus 1 in number 3. In number 4, we're going to be utilizing all the rules that we learned at the start. So we'll have 4 times the derivative of x to the 4th minus 5 times the derivative of x minus the derivative of 3. So using the constant multiple rule, we'll pull out a 4 with this first term of the function, and then we'll use the power rule to find the derivative of x to the 4th, which will be 4 times x to the 4 minus 1. Because remember, we're taking that exponent, multiplying it essentially by the coefficient, which is what we do in the constant multiple rule. When we pull out that 4, it will get multiplied by that exponent's value, and then we decrease that exponent by 1. And because of the sum rule, these will be subtracted. So we'll be applying the difference rule. So now I'm going to subtract the derivative of 5x, which is 5 times 1 times x to the 1 minus 1. Because this x has an exponent of 1, and applying the power rule, bringing the value of 1 down to multiply it to 5, and then decreasing that value by 1. And then lastly, we're going to be again subtracting the derivative of a constant, which we know the derivative of a constant is 0. So subtracting 0. Now let's simplify. 4 times 4 is 16, so I'll have 16 times x to the third, because decreasing 4 by 1 is 3, and then we'll be subtracting 5 times 1, which is 5, and then we're multiplying that by x to the 1 minus 1, which is x to the 0. However, x to the 0, that value is 1, and 5 times 1 is 5. So we'll have 16x cubed minus 5 as the derivative of f of x. Moving on to number 5, y equals 3 times x to the 5/4. So we're going to be applying the power rule. So we're going to have 3, and we're going to multiply that by the derivative with respect to x of x to the 5/4. So this is going to be 3 times in, which the exponent is 5/4, so that's 5/4 times x to the 5/4 minus 1. Simplifying, multiplying, we'll get 3 times 5, which is 15, so that's 15/4 times x to the 5/4 minus 1, which 5/4 minus 1, I'm going to write that 1 as 4/4, so I can subtract it. So I'll have 15 times x to the 5/4 minus 4/4 is x to the 1/4, and that's all over 4. So 15 times x to the 1/4 divided by 4 is the derivative of y with respect to x in number 5. In number 6, I'll have 5/4 times the derivative with respect to x of x to the 2/3. So this is going to be 5/4 times, using the power rule, 2/3 times x to the 2/3 minus 1. So 5 times 2 over 4 times 3, that's going to be 10 over 12 times x to the 2/3 minus 1, but I'm going to write 1 as 3 over 3. Now I'll simplify, because 10 over 12, both are divisible by 2. So I'll have 5 over 6 times x to the 2/3 minus 3/3, which is a negative 1/3. Now remember, if an exponent is negative, then I can write this as x to the positive exponent in the denominator. So my derivative of y with respect to x is going to be 5 all over 6 times x to the positive 1/3. Because remember, this was 5 times x to the negative 1/3 all over 6, but if I have a negative exponent, I can write that as a x to the positive exponent in the denominator. And that's how I got 5 over 6 times x to the 1/3. In number 7, I'll have negative 4 times negative 5 times x to the negative 5 minus 1. Negative 4 times negative 5 is a positive 20, and x to the negative 5 minus 1 is x to the negative 6. So the derivative of y with respect to x is going to be 20 all over x to the 6th, because remember, x to the negative 6 equals 1 over x to the 6th. So I'm moving x to a negative exponent into the denominator with a positive exponent. So 20 over x to the 6th is my solution in number 7. In number 8, I'm going to rewrite this as 3 times x to the negative 3rd, so that we can apply the power rule. So the derivative of y with respect to x is going to be 3 times n of negative 3, so that's negative 3 times x to the n minus 1, negative 3 minus 1. 3 times negative 3 is a negative 9, and that's x to the negative 3 minus 1, which is x to the negative 4. So the derivative of y with respect to x equals negative 9 all over x to the positive 4, which we can write as negative 9 over x to the positive 4. And that's my solution in number 8. In number 9, y equals x to the 2/3. So using that power rule, dy dx will equal 2/3 n times x to the n minus 1, or 2/3 minus 1, because 2/3 is equal to n for number 9. So that's going to be 2/3 times x to the 2/3 minus 1, which I can write as subtracting 3/3. So that's 2/3 times x to the negative 1/3. So this x is going to go in my denominator with the exponent as a positive. So dy dx, the derivative of y with respect to x, is 2 over 3 times x to the positive 1/3. And the last problem on the first page, number 10, I'm going to rewrite as negative 2 times x to the 1/4, because the fourth root of x is the same as x to the exponent value of 1/4. So I'll have negative 2 times n times x to the n minus 1, which is 1/4 times x to the 1/4 minus 1, which I'll write 1 in terms of 4, so that's 4 over 4. So I'll have negative 2 times 1/4 is negative 2 over 4 times x to the 1/4 minus 4/4 is to the negative 3/4. Now, simplifying, negative 2 over 4, that's the same as negative 1/2, and x to the negative 3/4 is equal to 1 over x to the positive 3/4. So the derivative of f of x is going to equal negative 1 over 2, the simplified version of negative 2/4, but that 2 in the denominator is multiplied by x to the positive 3/4. The derivative of f of x is negative 1 over 2x to the 3/4. Now onto the second page. Number 11, we're applying the power rule and the sum rule. So the derivative of y with respect to x is going to be 2/3 times 4 times x to the 4 minus 1 plus 5 times 1 times x to the 1 minus 1, because this x has an exponent of 1, and then minus negative 3 times x to the negative 3 minus 1. So simplifying, 2/3 times 4 is going to be 8/3, and that's times x to the 4 minus 1, which is x to the 3rd, plus 5 times 1 times x to the 1 minus 1 is 5 times 1, which is 5, and then I'll be subtracting a negative 3x to the negative 3 minus 1, but that's the same as adding a positive 3x to the negative 3 minus 1, which is negative 4. So simplifying further, the derivative of y with respect to x equals 8 times x to the 3rd over 3 plus 5 plus 3 over x to the 4th. And that's x to the positive 4, because x to the negative 4 is 1 over x to the positive 4. So the derivative of y with respect to x equals 8 times x to the 3rd over 3 plus 5 plus 3 over x to the 4th. Now the last problem in this section, number 12. I'll have negative 1/2 times 4 times x to the 4 minus 1. And then I'll be adding 3 times 5/3 x to the 5/3 minus 1, which I'll write 1 as 3/3. And then I'll be adding that to the derivative of 2x, which is 2 times 1 times x to the 1 minus 1, because x has an exponent of 1 for that third term. So negative 1/2 times 4 is a negative 2, and x to the 4 minus 1 is x to the 3, or x to the third. And then I'm going to be adding 3 times 5/3, which my 3 will cancel out that 3 in the denominator. So I'll have 5 times x to the 5/3 minus 3/3 is a positive 2/3. And then I'll be adding 2 times 1 times 1, which is 2. So the derivative of y with respect to x in number 12 equals negative 2x to the third plus 5x to the 2/3 plus 2. Now, before moving on to the next section, let's think about how much more tedious this would be if we didn't have the power constant in SumRules to help us find the derivative. Because in order to find the derivative, remember, we'd have to take the limit as h approaches 0 of f of x plus h minus f of x all over h, which would take us a lot longer than applying the power constant and SumRules. But if you ever get confused, remember you can always fall back on finding the limit. Now for our next section, we're going to be differentiating each function with respect to the given variable. So this is not necessarily dy with respect to x. We're given different variables, so we're finding the function's derivative with respect to that given variable. So looking at number 13, we're finding the derivative of y with respect to our variable r. But the same rules are still going to apply. So we'll have dy dr equal, using the constant multiple rule, I'll pull out that negative 3, and then the power rule, that's going to be times 5 times r to the 5 minus 1, and then sum rule, you can see we're subtracting, so really the difference rule, 5 times 2 times r to the 2 minus 1. So essentially, we're substituting x with r, and we're finding the derivative of y with respect to that variable r. So dy dr equals negative 3 times 5, which is a negative 15, times r to the 5 minus 1, which is r to the 4th, minus 5 times 2, which is 10, times r to the 2 minus 1, which is r to the 1st, or simply r. So the derivative of y with respect to r, dy dr, equals negative 15 r to the 4th minus 10r. Now on to number 14. In number 14, we're finding the derivative of f of s. But quickly, I'll rewrite f of s as negative 3 times s to the negative 2 minus 4 times s to the negative 4. So all I did was pull my variables out of the denominator by writing them as negative exponents. Now we can apply the power rule. So we'll have negative 3 times negative 2 times s to the negative 2 minus 1 minus 4 times negative 4 times s to the negative 4 minus 1. So simplifying, negative 3 times negative 2 is a positive 6, and s to the negative 2 minus 1 is s to the negative 3, and we're subtracting 4 times negative 4, which will be subtracting a negative 16 times s to the negative 4 minus 1, which is s to the negative 5th. So simplifying, we'll have the derivative of f of s equal to 6 over s to the third, because s to the negative third is the same as 1 over s to the positive third, and that's multiplied by 6. And then as opposed to subtracting a negative, we'll add the positive 16 over s to the 5th. So 6 over s to the third plus 16 over s to the fifth. So again, if our variable is to a negative number, we can write that as a variable to that positive value in the denominator, or vice versa at the start. If our variable has a positive exponent in the denominator, we can write that as our variable to the negative exponent in order to apply the power rule. Now on to number 15. We're finding the derivative with respect to our variable, and in this case, our variable is x. So we'll have 2/3 times 3/2 times x to the 3/2 minus 1, which I'll write 1 as 2/2, and then we're subtracting the derivative of our next term, which is 3/4 times 3/5 times x to the 3/5 minus 1, which I'll write that as 5/5. Now let's simplify. 2/3 times 3/2 will be 6/6, which will be 1. So we'll have x to the 3/2 minus 2/2, which is x to the 1/2, minus 3/4 times 3/5 is going to be 9/20, and that's multiplied by x to the 3/5 minus 5/5, which is x to the negative 2/5. So rewriting this, we'll have the derivative of x equal to x to the 1/2 minus 9 over 20 times x to the 2/5. One more time, the derivative of f of x equals x to the 1/2 minus 9 over 20x to the 2/5. And lastly in this section, we're finding the derivative of h of s. So the derivative of h of s is going to equal the square root of 2 times 1/3 s to the 1/3 minus 1, which I'll write as 3/3, plus the square root of 2 times 1/5 s to the 1/5 minus 5 over 5. And how I did this is I rewrote in my head h of s, the square root of 2 times s to the 1/3 plus the square root of 2 times s to the 1/5. And then I applied the power rule to s to the 1/3 and s to the 1/5. So now, simplifying, I'll have the square root of 2 times 1/3 times s to the negative 2/3 plus the square root of 2 times 1/5 times s to the negative 4/5. So the derivative of h of s is going to equal the square root of 2 all over 3 times s to the 2/3 plus the square root of 2 all over 5 times s to the 4/5. And that's my solution in number 16. Because the square root of 2 times 1/3 is the square root of 2 over 3, and then s to the negative 2/3 is 1 over s to the 2/3. And then the square root of 2 times 1/5 is the square root of 2 over 5, and that's multiplied by s to the negative 4/5, which is 1 over s to the 4/5. Now, on to our last problems, 17 and 18. For 17 and 18, we are to differentiate each function with respect to x. And that is the key. It's with respect to x. So problems may contain constants a, b, and c. So looking at number 17, if we're finding the derivative of y with respect to x, dy dx, well, looking at y, all we have is a constant, because remember, c is a constant according to our instructions, and a constant times a constant will give us a constant, so the derivative of y with respect to x is 0 for number 17. Now let's look at number 18. In number 18, we have 4 ax to the 3a minus bx to the 3c, where a, b, and c are constants, so we're differentiating with respect to x. So the derivative of y with respect to x is going to be 4 times a times, looking at x to the 3a, that's going to be 3a times x to the 3a minus 1. Applying the power rule, where n is equal to 3a, that's 3a times x to the 3a minus 1. Because 4a was that constant, we were able to pull it out. Then we're subtracting b times the derivative of x to the 3c, which is 3c times x to the 3c minus 1. Remembering the power rule, n times x to the n minus 1, 3c times x to the 3c minus 1. Now let's simplify. 4a times 3a is going to be 12a squared, and x to the 3a minus 1 we cannot simplify, so that 12a squared will be multiplied by x to the 3a minus 1. Then we're subtracting b times 3c times x to the 3c minus 1. So that's going to be subtracting 3 times b times c times x to the 3c minus 1, because 3c minus 1 can also not be simplified. So our derivative of y with respect to x equals 12 times a squared times x to the 3a minus 1 minus 3bc times x to the 3c minus 1. That is our simplified derivative in number 18. And again, that's because our a is a constant, our b is a constant, and our c is a constant. So with that, we wrap up the differentiation, power, constant, and sum rules worksheet. If you have any questions, please remember to put them in the comments below. And if you haven't done so already, don't forget to like, subscribe, and share. All likes and subscriptions are greatly appreciated, as well as sharing this video. And if you want more ways to support me, go to maemap.com, maemap.com for more information. Also remember to check out the video description for links to my website, to this worksheet, and to my Patreon page.